Hi guys, welcome back to my channel. I'm here in front of you to give my tutorial with the chapter 5, which is Ethernet. So here the introduction with the chapter 5 Ethernet. The OSI physical layer provides the means to transport the bits that make up a data link layer from across the network media. At the same time, Ethernet is now the predominant LAN technology in the world. Because Ethernet is compromised of standards of these lower layers, it may best be understood in reference to the OSI model. The OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standards of the media. So let's start. So here we have the internet encapsulation. So the internet encapsulation here are the layers that are responsible for encapsulating. We have the data link and the physical, and our sub layers. Then here are internet evolution, as you can see, from the year 1973 to 2016. Then standard Ethernet, next is standard Ethernet. It is Ethernet as well. So these are the Ethernet frame structure and field size. We have the 8 bytes, 6 bytes, 68 bytes, 2 bytes, 46 to 1500 bytes. Okay, I've here we have here an activity, so I'm going to answer it in order for you to know more about the MAC and the LLC. So the activity is named as MAC and LLC sublayers. So you have to describe which of these part are a MAC or an LLC. So let's start. First, we have the controls, the interface card, through software drivers. So it is considered as LLC. It is considered as LLC because it contains the uses a software drivers that needed in LCC, and also the controlling networks and interface. Then second one is work with the upper layers to add application information for delivery of data to higher level protocols. So it is called also an LLC. Then third, works with hardware to support bond with requirements and checks errors in the bit sent and received. So it is distinguished as MAC. Then control access to the media through signaling and physical media standards requirements. So it is a MAC. It is considered as MAC because control access to the media, same physical media standards requirements. So supports the Ethernet technology. We have the CSCMA, CD or CSMA CA. So it is MAC. So let's go with the third activity, the identify Ethernet frame field names. So we have uses path to increase this frame field to at least 64 bytes. This is used as 802.2 header and data, distinguished as 802.2 header and data. This was standards. So describe which higher layer protocol has been saved. So it is classified as type. Then the frames organizing NIC or interface MAC is source address because of the IP addressing, the subnetting, and the access a host and determining if the frame receives an address to it. So it's classified as destination address. From the source address, we have the destination address for transmission of data, and notifies destination to get ready for a new frame. It is a preamble. So synchronizes sending and receiving devices for frame delivery. It is the start of frame delimiter from the word synchronizes. It manages and it holds or it differentiates from the receiving data from the frame delivery. And the last, detect errors in the internet frame, which is frame check sequence. Then we have address here. Then we have the MAC address internet identity. We have internet every network device and connected to the same shared media. Internet was once predominantly a half duplex topology using a multi-access bus or later internet. So we have the conversion here. Organization unique identifier or OUI. We have 24 bits transferred in the window of vendor assigned NIC interfaces. We have 24 bits also, 6 hex digits, as well as the vendor. We have the 6 hex. Then we have difference with the 00-60.f. On the other side, we have the 3A07 BC and Cisco particular network. In Ethernet, every network device is connected to the same shared media. Ethernet was once predominantly a half duplex topology using a multi-access bus or later Ethernet hubs. These metasis nodes would have received been transmitted to prevent the excessive overhead involved in the processing of every frame MAC addresses. So we have MAC address, what we call MAC address structure. MAC address structure, we have the MAC value is directed result IEEE enforces rule of vendors to ensure globally unique addresses, or the IEEE standards. Always having the standards in order to have the specific or standard network frame. So let's play this video, the what we call the frame forwarding. So from the PC1 needs to transfer a data using a source address and destination address. So this is mine, this is transferred into, it is multicast sent to all, but some pieces ignore it because they are this is not addressed to this is not addressed to them, so they just ignore it, and for the PC that accept it is considered that it is mine. So here, from the frame forwarding methods on Cisco switches, we have the what we call the store and forward switch and a cut through. Then a stored and forward switcher receives the enter frames and computes the CRC. The switch looks up the destination address, which determines the outgoing and interface. The frame is then forward of the connect port. So a cut through switching towards the frame before it's entirely received. Destination address of the frame must be read before the frame end. So it is somehow different with difference with their functions. And we have figure 2. Store and forward switching representation, and store forward switching receives the enter frame. So let's play it further for us. So as you can see, we have the destination address, source address, the data, and the CRC. It is transferred through switch and converted to CRC, and the frame is good. So switching table. So after it's converted, it is transferred to its destination. So this is the process of frame forwarding methods of Cisco switches. So let's go for our third activity. the frame forward methods. So frame forwarding methods, we have to distinguish if it's start and forward and the cut through. So let's start with first. We have buffers frames until the full name has been received by switch is classified as store and forward. Checks the frame for errors by receiving its store and forward. No errors checking on the frame's performance. The switch before releasing the frame out of its port, so it is classified as cut through because of its switching processes. Then a great method used converse, it is used as store and forward. The destination network interface is currently complete from using this frame forwarding method, so it is cut through because some forwarding method. The faster switching method, but may errors in data integrity, therefore more bandwidth may be consumed. So from the true bandwidth, it is cut through switching. So from the address solution protocol, we have what we call the MAC and IP address. The destination network, so this is the destination MAC address. As you can see, this is the MAC addresses connected through NIC ports, and NIC ports connected, and the original source and its final destination. The data is transferred, and using the guidelines or the MAC addresses, the data transferred successfully. We have the ARP. So this is what we call the so-called ARP, the video demonstration, so-called ARP, the target IPv4 address and the target MAC address. And the ARP issues. Also we have the ARP issues. ARP broadcast can flood the local media, so having a problem with the flooding of the data, so the broadcast frame and ARP request is received and proceed by every device on the local network. And after the device sent out the initial ARP broadcast and have learned the necessary MAC addresses, any impact on the network will be minimized. So that's all for the tutorial of this chapter. So hope you learn and understand. Thank you for watching.